In this video, I'm going to talk about two theorems that apply to general triangles. So when I say a general triangle, I just mean any triangle, not necessarily a right triangle. And so when we have a general triangle, such as this one here, we have to label in a very specific way. So the convention is that we label with either uppercase or lowercase letters, and then the sides that are across are the opposite of that, right? So capital B, lowercase b, capital A, lowercase a. And so once we have this setup here, so this is our general triangle setup, we have two major theorems that we can use. The first is called the law of sines, and the law of sines basically takes angle and side and pairs them in this fraction. And if you do this, these will always be equal. So if you take sine of an angle and divide by that side length, this will be equal to any other angle and side length pair. And so when you use the law of sines, you typically only want to have two sides of the equation. And the labeling, the letters, doesn't matter which letters you use, right? Because the letters are arbitrary. The second major theorem is the law of cosines. And I wrote the law of cosines a little differently than most people are probably used to. I did this on purpose to emphasize that the letters don't matter, right? It's the relative pattern of the formula that matters. So one major thing to note about the law of cosines is that the angle that's in cosine here has to be on the opposite side of the equation that the side is, right? So this is the side that matches, the angle that's here. And that has to be by itself, right? And the rest of the formula, we also have this pattern, right? So the two smaller sides, or the two adjacent sides, I should say, those are squared. These letters will always match the letters before cosine, right? So that's important. So just to emphasize this, I could write this law of cosines using any other angle, right? As long as I choose an angle and remain consistent. So for example, I could choose the angle A. So if I choose A for the angle, then A squared is going to be the side by itself. And then the other two sides are going to be B squared plus C squared. So again, the two squares here are what goes there. So this is minus 2BC times cosine of the angle that matches this is A, right? So the exact letters you use are not necessarily important, but what is important is the relative setup, right? So the angle on the side that matches the angle on opposite sides. So we have these two laws, and we want to know which one to use. So how do we decide which law to use? So the key thing to note here is that the law of sines, to use this, you need two sides. So it involves two angles and two sides, right? So this is two angles and two sides. So this is what we need if we're going to use the law of sines. Another way of thinking about this is two side angle pairs, right? Side angle pairs, that's probably a better way of thinking about it, because the angle is paired with the side. Law of cosines, on the other hand, involves one angle, and then everything else here is sides. So law of cosines, you have three sides, one angle. So that's the difference. So let's go ahead and do a quick example. So in each of these cases, there's four cases here. There's a letter, and the letter is the unknown, right? So the letter is the unknown that we want to solve for. And so take a moment, pause this video, and maybe see if you can decide which law you would use in each case. Would you use the law of sines or the law of cosines? So take a moment, pause the video, and just briefly think about which one you would want for each. And hopefully you did that. So in each case, we want to ask, do we have sides? Do we have angles? How many of each, right? So let's look at the first case. So first case, we have A is the unknown. That's a side. And then we have known values for a second side, a third side, and we have a known value for an angle, right? So this is 3 sides, 1 angle, and there's only 1 unknown, right? That's the key. You can't have more than 1 unknown. So one of those is unknown, the other 3 are known. And so it happens that 3 sides, 1 angle are what we have. So this is law of cosines. Law of cosines. So let's see. So going down here, we have an unknown angle B. We don't know any other angles though. We have a side, a side, a side. So again, we have 3 sides, 1 angle. So this is law of cosines. And it doesn't matter which one the unknown is. So in this previous example, A was the unknown, the side was an unknown. And in this case, the angle is unknown. It doesn't matter if it's a side or an angle, as long as there's only 1 unknown. So we have 1 unknown, all the other 3 things involved are known. We have a number for those. So it's really important that we only have 1 unknown. So this next case is going to illustrate that, right? So here, A and B are both unknown. So we can't use both A and B, right? We only want 1 unknown. Want 1 unknown. So we can't use both A and B, so therefore we only have 1 angle here, right? But fortunately, we do have 3 sides that are all known. So again, for the third case, we have law of cosines. And finally, up on top, A is our unknown, it's a side. Well, there's no other unknowns here, but we do have 3 things that we do know. We have a second side, so that's 2 sides. And we have 2 angles, and they're both known. 2 sides, 2 angles, and they are, oh, they're not paired in this case. So we need them to be paired, right? So 5 and 40 are paired. However, our unknown here, we need to pair it with this angle here. So we have this unknown angle. I'm going to use little a in this case. However, we can actually figure out little a, right? Remember that angles add to 180. So angles add to 180 degrees. So this is 20 plus 40 is 60. So in this case, A is going to be 120 degrees. These triangles are not drawn to scale, by the way, so it wouldn't actually look like this. But in this case, A is 120 degrees based on those. And so now A is a known angle, and that angle is paired with the side we want. And so 2 side angle pairs, right? 2 side angle pairs. So 2 pairs. That is law of sines. So that's how you determine which law to use. You just want to tally up which sides and which angles you have, how many of each, and remember, only 1 unknown is allowed. So that's all.